50 megawatts in 90 days looked like a breakthrough. But 1 hour before Pabré was inaugurated, Burkina Faso launched something more than twice as large, a planned 120 megawatt power station, costing an estimated 133 billion CFA francs. Building fast was the first test. Scaling without losing control is the next. Can Burkina Faso finance the project, secure fuel, maintain the generators, strengthen the grid, and keep electricity affordable? Or will a larger plant create a larger dependency? Pabré proved Burkina Faso could move fast. Ouaga Sud-Est will reveal whether it can truly scale under national control. Pabré and Ouaga Sud-Est are not the same project, and that distinction defines this story. On July 21, 2026, Burkina Faso inaugurated the emergency thermal power plant at Pabré. The government announced a capacity of 50 megawatts, a cost of 18 billion CFA francs, and a construction period of 90 days, 30 days faster than the contractual schedule. About 1 hour earlier, officials had placed the foundation stone for the future Ouaga Sud-Est thermal plant in Saaba. Its projected capacity is 120 megawatts. Its estimated investment is 133 billion CFA francs. Those numbers are real announcements, but they describe a project at the beginning of construction, not electricity already flowing into the grid. That difference matters. Pabré can be evaluated through commissioning, operating output, fuel use, maintenance, and grid performance. Ouaga Sud-Est must first pass a different set of tests financing procurement, civil works equipment, delivery installation, connection testing, and final commissioning. The official announcement presents Pabré as the first milestone in a wider program designed to increase domestic generation and reduce exposure to interruptions from imported electricity. It also says additional plants are planned for Bobo Dioulasso, Kudugu Kaya Komsilga, and Toese, together representing more than 220 megawatts of additional capacity. That urgency fits a wider target plan. Relance aims to raise energy capacity from 685 megawatts to more than 2,500 by 2030. It remains a target, not delivery. But planned capacity is not delivered energy. A foundation stone does not prove a construction schedule. An estimated budget does not prove the final cost. And a projected 120 megawatts does not prove the plant will operate at that level every day. Tell us what country you are watching from and subscribe as we track whether Burkina Faso can turn energy announcements into reliable national power. Because the first milestone has been completed. The second has only begun. And the gap between those two stages is where the real risk appears. Why does Burkina Faso need a plant more than twice the size of Pabré? And what economic system is waiting for that electricity? 120 megawatts matters because Burkina Faso's industrial strategy is creating electricity demand faster than one emergency plant can satisfy. Every factory inaugurated, irrigation pump installed, cold storage facility opened, and urban district expanded adds another load to the system. Pabré's 50 megawatts can strengthen supply, but it cannot solve every constraint alone. Ouaga Sud-Est is intended to be more than a larger generator. Its projected capacity is more than twice Pabré's, making it a possible anchor for factories, hospitals, water systems, businesses, and households. Electricity is the hidden input behind nearly every self-reliance project. A tomato plant cannot process a harvest when motors stop. A maize factory cannot mill grain through repeated outages. A gold refinery cannot add value locally without stable power. A hospital cannot protect medicine or operate critical equipment on unreliable supply. And a workshop cannot compete when it must buy fuel for a private generator. The real value of 120 megawatts is not the number written on the plant. It is the amount of production that reliable electricity can keep alive. But new capacity creates a new obligation. The plant must deliver power at a cost factories and families can afford. If electricity becomes available but remains too expensive, industrial expansion can still stall. Burkina Faso's plan, Relance, targets an increase in national energy capacity by 2030. Ouaga Sud-Est is one announced piece of that ambition, not proof the target has been reached. So the question is not simply why Burkina Faso wants more power. It is whether this project can convert planned megawatts into reliable production, lower interruption risk, and economic capability. Before that can happen, Burkina Faso must build and finance a machine far more complicated than the number 120 suggests. A 120 megawatt power station begins long before the first generator turns. The project starts with land engineering financing and a construction schedule that must coordinate dozens of systems at once. Civil works must prepare foundations strong enough for heavy generating equipment. Fuel storage drainage, fire protection, cooling, control rooms, workshops, transformers, substations, and transmission connections must all be designed to function as one system. Each stage creates a possible delay. A late equipment shipment can stop installation. A design change can increase cost. A payment dispute can slow contractors. A missing transformer can leave completed generators unable to deliver electricity. That is why Pabré's 90-day construction record cannot automatically be applied to Ouaga Sud-Est. Pabré was announced as a 50-megawatt emergency plant costing 18 billion CFA francs. Ouaga Sud-Est is projected at 120 megawatts with an estimated investment of 133 billion CFA francs. The larger number does not simply mean more engines. It means more fuel handling, more electrical equipment, more protection systems, more grid coordination, and a larger maintenance burden after commissioning. Financing creates the first hidden test. Is the full capital available from the beginning, or will construction depend on stage payments? Who carries the risk if imported equipment becomes more expensive, currency conditions change, or the project schedule expands? Procurement creates the second test. Who manufactures the generators, transformers, control systems, and critical components? Are spare parts included in the contract? Will technical documentation, software access, and diagnostic tools remain available after installation? Training creates the third test. Burkina Faso engineers and technicians must participate before commissioning, not only after foreign specialists leave. They need practical access to installation testing, fault diagnosis, maintenance schedules, safety procedures, and major repairs. A plant can be nationally located while its deepest technical knowledge remains outside the country. Then comes grid connection. The station must be synchronized, tested, protected, and connected without destabilizing the network. Transformers and lines must carry the output while operators balance generation with changing demand. The strongest construction result is therefore not a finished building. It is a plant delivered near budget, connected safely, supported by trained local teams, and supplied with the parts and knowledge required to operate for years. Because technical choices made during construction will shape fuel costs, breakdown time, and electricity prices after launch. Pabré proved that speed is possible. Ouaga Sud-Est must prove that scale can be managed without turning a larger project into a larger vulnerability. And even if construction succeeds, the next question remains: who receives the new electricity first? When 120 megawatts enters the grid, the first political question is not how much electricity exists. It is who receives reliable power first. Large industrial users may be prioritized because factories, mines, water systems, and public infrastructure can absorb major loads and generate jobs, taxes, and exports. That can be economically rational. A tomato processor loses an entire harvest when the line stops. A hospital cannot protect medicine or operate critical equipment through repeated outages. A mine or refinery may suspend production when voltage becomes unstable. But national capacity does not automatically become household reliability. A new power station can increase total generation while neighborhoods still face outages because local transformers are overloaded, distribution lines are weak, or connection costs remain unaffordable. Rural areas face an even harder test. A village without a strong distribution network may gain nothing from 120 megawatts generated near Ouagadougou. Electricity must travel through substations, transmission lines, transformers, and local networks before it becomes light, refrigeration pumping, or productive work. That creates an allocation problem. Should new power first stabilize industries that can strengthen the economy? Should hospitals, water systems, schools, and security infrastructure receive priority? Should households with the highest outage burden come first? Or should electricity be allocated according to whoever can pay the most? There are two possible futures. In the first, new generation reduces blackouts, supports factories, lowers dependence on private diesel generators, expands irrigation, and improves service for households and public institutions. In the second, major commercial users receive the strongest supply, while ordinary communities continue facing weak distribution, high connection costs, and unreliable service. There is no evidence proving that second future will define Ouaga Sud-Est, but the risk must be measured. More national power should be judged by outage frequency, voltage stability, connection rates, industrial operating hours, and whether rural and low-income users experience real improvement. The fairest system does not distribute every megawatt equally. It distributes electricity according to transparent priorities, public need, economic impact, and the ability of the grid to serve each area safely. Because a power plant can increase national capacity without changing daily life for millions of people. And even if Burkina Faso decides who receives the electricity, another dependency remains. Who supplies the fuel technology and foreign currency required to keep the generators running every single operating day? Burkina Faso's 120 megawatt plan reaches its hardest test when the discussion turns to dependence. The goal is not to reject every foreign machine fuel supplier, loan software system, or technical partner. The goal is to prevent one outside decision from stopping the entire plant. That risk matters because Burkina Faso has historically relied heavily on imported electricity. In 2024, national production supplied about 51% of total electricity, while the remaining share came from outside the domestic production system. Pabré and Ouaga Sud-Est are meant to strengthen generation inside the country. That can reduce exposure to failures on regional interconnections and give Burkina Faso greater control over when and where electricity is produced. But domestic generation can still contain external dependence. A thermal plant may generate electricity inside Burkina Faso while its fuel is purchased abroad. Its engines may operate in Saaba, while major spare parts, diagnostic software, electronic controls, lubricants, and specialist maintenance come from foreign suppliers. The country may reduce imported electricity, but increase demand for imported fuel equipment and foreign currency. That does not make the project a failure. It defines the sovereignty test. The regulator reported that thermal generation already led the domestic mix in 2024, making fuel pricing, engine availability, and maintenance central national questions for energy security. Can Burkina Faso negotiate fuel from multiple suppliers? Can it maintain strategic reserves? Can local technicians complete routine maintenance and major repairs? Are critical filters, pumps, injectors, sensors, bearings, and control components stored inside the country? Can the plant keep operating when global fuel prices rise, transport routes are disrupted, or one supplier delays delivery? Cost creates another pressure. A thermal station does not stop charging expenses when electricity demand falls. Fuel staffing, maintenance, debt service, spare parts, and grid support must still be financed. If those costs rise sharply, the country may produce more electricity at home, while factories and households face higher tariffs or larger public subsidies. That is why energy sovereignty cannot be measured only by the share of electricity generated nationally. It must also be measured by fuel security, repair capability, supplier diversity, operating costs, and the ability to keep power affordable. The strongest model is not isolation. It is bargaining power. Burkina Faso should be able to use foreign technology without becoming trapped by one manufacturer, one fuel route, one software license, or one maintenance contractor. Pabré showed that domestic generation can expand quickly. Ouaga Sud-Est must show that a larger thermal system can remain fueled, repairable, and financially sustainable. Because producing electricity at home is only the first layer of control. The next layer is whether that electricity can leave the generators, cross the grid, and reach users without being lost behind weak infrastructure. Electricity becomes useful only after it leaves the generator and survives every stage of the grid. At Ouaga Sud-Est, power would first move through transformers that raise voltage for efficient transmission. From there, it must enter substations, cross high voltage lines, and then pass through local distribution equipment before reaching factories, hospitals, businesses, farms, and homes. Each stage can limit the value of the plant. A generator may be ready while a transformer is delayed. A transmission line may exist while one overloaded substation restricts the flow. A neighborhood may sit close to national generation, yet still face outages because local cable switches or transformers cannot carry the demand. That is why 120 megawatts of installed capacity is not the same as 120 megawatts delivered to users. The grid must balance supply and demand every second. When consumption rises quickly, operators need enough available generation reserve capacity and protection systems to prevent instability. When one unit stops for maintenance, another source must respond. If the system lacks backup, one technical fault can spread into a wider interruption. Transmission losses create another test. Some electricity is lost as heat while moving across lines and equipment. Weak infrastructure, long distances, overloaded networks, and poor maintenance can increase those losses, forcing the country to generate more power than customers finally receive. New generation may also require new transmission corridors, land access compensation, security and maintenance roads, meaning the grid expansion can face delays even after the power plant itself is technically complete. Then comes synchronization. The plant's voltage frequency and phase must match the national grid before connection. Protection systems must detect faults and isolate damaged sections quickly. Control rooms need reliable data-trained operators and clear procedures for responding to sudden changes. A large thermal plant also needs planned downtime. Engines, pumps, cooling systems, filters, transformers, and control equipment require inspection and maintenance. If the country treats every shutdown as failure, maintenance may be delayed until a more serious breakdown occurs. The strongest system measures reliability honestly. How many megawatt hours enter the grid each year? How often are units unavailable? How much energy is lost before reaching users? How frequently do customers experience outages? How long does restoration take? And how much of the repair work can local teams complete without waiting for outside contractors? Ouaga Sud-Est could add major generation near the capital. But if transmission and distribution upgrades do not keep pace, part of that capacity could remain trapped behind weak infrastructure. A power station creates electricity. The grid creates access. And the final success of 120 megawatts will not be measured at the generator terminals. It will be measured in factories that operate longer, hospitals that remain powered, pumps that keep running, and households that experience fewer interruptions. That leads to the final human test. Can businesses and families rely on this electricity, and can they afford what it costs to produce? The true value of 120 megawatts will be measured in routines, not inauguration speeches. For businesses, reliable electricity can reduce dependence on diesel generators, extend operating hours, protect machinery, and lower production losses. A maize mill can finish a shift without interruption. A cold storage facility can preserve food overnight. A workshop can keep machines running without spending heavily on emergency fuel. But more supply does not automatically mean lower costs. Thermal generation requires fuel maintenance, staffing, spare parts, debt service, and grid investment. If those expenses rise, businesses may receive more reliable power while still paying tariffs that limit expansion. Households face a similar test. Fewer outages can improve lighting, refrigeration, communication, study time, and household security. But families benefit only when connection fees and bills remain affordable. A community can sit near new generation and still rely on candles, batteries, or small generators if the final connection is too expensive. Agriculture adds another layer. Reliable electricity can support irrigation, pumps, cold rooms, grain storage, food processing, and water systems. It can help farmers protect more value after harvest instead of losing crops to heat delay or failed equipment. Public services also depend on the outcome. Hospitals need stable power for medicine, oxygen systems, laboratories, and surgery. Schools need lighting and digital equipment. Water networks need pumps. Local governments need functioning offices and communications. The project should therefore be judged through practical indicators. Do factories reduce generator use? Do outage hours fall? Do hospitals experience fewer interruptions? Do rural businesses receive new connections? Do households pay less for backup energy? Do farmers gain reliable power for pumping, storage, and processing? And does the state finance fuel and maintenance without weakening other public priorities? A megawatt has no social value until it becomes productive work, affordable light, preserved food, or reliable public service. That is the human test of Ouaga Sud-Est. The plant may add 120 megawatts to national capacity. But success will depend on whether that electricity becomes reliable enough for industry, affordable enough for families, and widely distributed enough to change daily life beyond the capital. Because the final question is not whether Burkina Faso can build a larger power plant. It is whether the country can turn every megawatt into economic capability without transferring the costs to the people it was meant to serve. Burkina Faso has already delivered one visible result. Pabré was inaugurated with an announced capacity of 50 megawatts, a reported cost of 18 billion CFA francs, and a construction period of 90 days. Ouaga Sud-Est is different. Its projected 120 megawatts, an estimated 133 billion CFA francs, describe a project that has begun, not power already reaching users. That is the first layer, what has been delivered. The second layer is what remains unproven. Public announcements do not yet establish the final construction cost, completion date, commissioning schedule, fuel contract operating efficiency, maintenance plan, tariff impact, grid upgrades, or actual electricity delivered from Ouaga Sud-Est. Those results must be measured, not assumed. The third layer is the 5-year test. Can Burkina Faso finish the plant near budget? Can it secure fuel through reliable and diversified supply routes? Can Burkina Faso technicians maintain engines, pumps, transformers, software, and protection systems without long dependence on outside contractors? Can the grid absorb the new capacity and deliver it beyond major industrial users? Will factories reduce generator use? Will hospitals, water systems, farms, and households experience fewer interruptions? And can electricity remain affordable after fuel debt maintenance and network costs are included? Pabré deserves credit as evidence that Burkina Faso can expand domestic generation quickly. But speed alone is not energy sovereignty. Ouaga Sud-Est must prove scale, reliability, affordability, and operational control. The strongest proof will not be the foundation stone or the inauguration ceremony. It will be annual megawatt hours delivered, fewer outage hours, shorter repair times, trained local teams, secure fuel reserves, lower dependence on emergency imports, and electricity that supports production without overwhelming public finances. Burkina Faso's wider ambition is to raise energy capacity from about 685 megawatts to more than 2,500 by 2030. Ouaga Sud-Est is one test inside that much larger promise. Pabré showed that the country can move fast. The real question is whether Burkina Faso can build a power system that still works, remains affordable, and stays under growing national control long after the construction headlines disappear. After the political celebration has finally ended. Disclaimer: this video is produced for documentary, educational, and analytical purposes. It examines officially announced projects, stated capacities, investment estimates, potential economic benefits, and implementation risks. The announced 120 megawatt capacity and estimated 133 billion CFA investment relate to a project that has been launched but has not yet been completed or commissioned. They should not be interpreted as verified operating output or final project cost. This analysis distinguishes between completed infrastructure, announced objectives, projected capacity, and results that still require verification over time. It does not claim that Burkina Faso has already achieved complete energy independence.